I help you guys to find the common difference, so you guys should be able to answer this. Okay? So now we can move on to the fun questions. Since you guys already know the definitions of the vocabularies that were given to you in the beginning of this lesson, you guys should be able to answer these problems. So I would like you guys to pause the video and come back to know the answer after you solve these patterns. Okay? Oh, I'll add one more problem here. Okay, pause the video and identify if either one of these or more than one of these is an arithmetic sequence. And make sure to use your vocabularies that was learned earlier to talk about why you chose this specific sequence as an arithmetic patterns. Okay, so come back when you're ready to discuss the answer. And yes, let's all love math together. Oh no. Okay, so I'm assuming that you guys have already paused the video and you guys are ready to discuss the answers. So for the first one, yes, it is a pattern. It is an arithmetic sequence because we have a preceding terms with a common difference of, what is it? Yes, good job, 5. Oh, that's an ugly 5. Sorry, let me rewrite that. Okay, good job, 5. Okay, because in order to get from 3 to 8, we added 5. From 8 to 13, we added 5. From 13 to 18, we added 5 again. From 18 to 23, we added 5 again, and so on. What about the second one? Yes, no, because no, it's not an arithmetic sequence because the pattern does not have a common difference, nor a recursive pattern. Recursive pattern. Nor a recursive pattern. Okay, heads up. Make sure you guys still remember what these words mean, because I know we never really talked about it, but we will be discussing about it for the last problem. So yes, though this is not an arithmetic sequence because from 5 to 25 they added 20, but from 25 to 125, they added 100. From 125 to 625, they added 600. Like, are they adding a fixed number, meaning just one number, like just one type of number in order to get from the previous number to the next number? No, they're adding all kinds of numbers to get to the next term. That's why this is not an arithmetic sequence, because there's no common difference. Yes. Next one. Yes, same thing as the previous one. This is not being added with a fixed number again. So because from 1 to 6, they added 5. But from 6 to 2, they subtracted 4. And from 2 to 2, it's just they added 0. So it's a weird pattern. It's not even a pattern. It's a weird arrangements of numbers. That's what this is. That's why it's not an arithmetic pattern, because there's no common difference nor a recursive pattern. What about the next one? Yes, no again, because again, from 1 to 4 is they added 3. From 4 to 9, they added 5. From 9 to 16, they added, yes, they added 7. So they're not adding a fixed number to every term, so it doesn't have a common difference nor a recursive pattern. How about these? What would be the next picture look like? What can you guys observe based from the first, second, third, and fourth term? How much is being added? Or how are they getting the next picture based from the previous picture? I want you guys to think for a few minutes and come back when you're ready to discuss the answer. Okay, I'm assuming that you guys paused the video. You guys better not be cheating. And now ready to discuss the answer. So, from the first let's discuss that later. So from the first pattern, or I mean from the first term, we have just a single dot. And then to gain the next term, from having just a single dot, they added one dot and also one dot on the top. Okay, so to get the third term, so let me just draw what we have from the previous picture. To get the third picture, they added 1 to the bottom, 1 to the top, and make sure you have a single, just one dot on top of every layer. So you guys can see the pattern. So the pattern is that this one is being moved to the top. Oh, sorry. Oh no. So what I'm trying to say here is that they're getting the next visual based from adding a numbers of balls on the bottom of it. Like for instance, this one is basically on top of these, and this one is basically on top of these. So how much is gonna be on the bottom for the next figure? It's gonna be 4 balls, and then we're gonna add this entire thing on top of it. So the next one is gonna be, so if this has 1, this has 2 on the bottom, and this has 3 on the bottom, and this has 4 on the bottom, how much balls is gonna be on the bottom of our 5th figure? Yes, 5. 3, 4, and 5. And this whole thing is gonna go on top of it. 2, 3, 4. So this is how the 5th figure will look like. And yes, this is a recursive, yes, this is an arithmetic pattern. Because it has a recursive arithmetic sequence. Because it has a recursive pattern. And remember, recursive pattern is a number that is being added from the previous term to get to the next term. Okay, I hope you guys enjoyed this lecture. And again, feel free to email me if you guys have any questions. And my email is villamarmarj@gmail.com. Okay, feel free to email me if you guys have any